East Coast. I am from the East Coast. I grew up in Northern Virginia, about 20 miles south of DC. My dad was a Marine, and my mom, her first job was a secretary at the Department of Treasury. So we spent some time visiting Delaware, or at the very least driving through on our way up to Massachusetts to visit Nana for Thanksgiving. But it's lovely to see you all and be connected back with some East Coast friends. I've been out in California now for about 20 years. And it's lovely in many ways, but I do sometimes miss the East Coast. Awesome. Some other DC folks in the room. Well, as they said, to introduce me, yep, I'm a PhD candidate finishing up my dissertation right now, and I've been focusing my entire educational career on working with multilingual students. And as time passed, I started to focus in on math education because my teacher education focused on promoting discussion and student participation and democratic teaching methods. And it was all working really great for me when I was teaching literature, when I was teaching writing, when I was teaching history, things like this. But when it came to math and science, I didn't have a lot of professional development about how to make that more participatory for my students. It became very much about obedience. We're going to look at page 23 and do what they say. Follow my instructions and do it just my way and you'll be fine. And that is what brought me to a PhD program, because I thought surely there's a way to make math and science instruction as engaging, as participatory, as honoring of student ideas as I'm doing in my literature lessons, in my history lessons and things like that. And I've been doing this PhD now for 7 years and I've learned a ton. I've had the opportunity to write with some really fabulous co-authors. And so today my goal is to share some of those ideas with you, some of what I've been learning and thinking about, hear some of your thoughts on it, and go from there. And hopefully our goal that we share is to make learning experiences better for everyone, but particularly our multilingual learners. To give you a little bit of context, my teaching experience was 4th, 5th, and 6th grades, always in a self-contained classroom in schools that had lots of multilingual learners. My first 4 years of teaching were in a school that was over 85% multilingual learners, but they didn't all speak the same language. And some of them were newcomers speaking language that I had no experience with. So I really had to struggle with how to produce good learning experiences for them within a context that was not only challenging for me as a teacher because of the diversity of languages and experiences in my classroom, but also because of the expectations placed on me as a teacher by the policies at the state, county, and district level. I was teaching during No Child Left Behind, and there was a lot of pressure around raising our test scores and making sure that our multilingual learners were showing growth on their state assessments and things like that. And a lot of the recommendations I was getting for teaching, and sometimes even the requirements, the demands placed on me for teaching, were not necessarily based on research around how students learn, how multilingual learners learn. I was given things like a list of academic vocabulary that I had to make sure my students mastered. And we now know, of course, that a list of words is not a really good way to learn vocabulary for anyone. That's not how we as humans learn language. But that was sort of the instructional materials that I was expected to work with. And I don't know if you all have any experience with things like that, but it can be very frustrating when what you know as an instructor doesn't match necessarily what you're being told to do. The presentation that I'm going to share today hopefully can show you some ways that even if you find yourself working, maybe not in Delaware, you move to a new state and you find yourself working someplace that isn't recommending the best practices for working with multilingual learners, you can still have these ideas in your back pocket that can work in any context. So I'm going to start by trying to share my screen and go into presenter mode. And so you all can see slides, yes? Awesome, thank you very much. So I'm going to be talking about this paper that I wrote, and we call it Noticing the Multilingual and Non-Dominant Student Strengths for Learning Math and Science. And we have this framework that centers the idea of professional noticing. And if you think about your experience as a teacher, there's the buzz of everything that's happening in the classroom. It's busy. You have at least 30 students, maybe 40, all talking, communicating with one another. Things are happening, not to mention all of the other stuff that's going on in the context of the school around you. And with all of that buzz and busyness, how do we learn what to pay attention to? How do we learn what to notice? And some of that comes from what we're taught in our teacher education program. Some of that comes from professional development, but a lot of it also comes from our ideas that are culturally and socially built. Think about those conversations you have with other teachers about what's going on in your class. Think about your own socialization as a student growing up. Like, what did it mean to be smart at math or science? What did that look like? And then think about how we may reproduce some of those cultural ideas. Maybe it means being fast. Maybe it means being accurate. Maybe it means having all the right vocabulary or having the procedure memorized, things like that. These sorts of cultural notions reproduce ideologies that may mean that we're overlooking the strengths that our multilingual learners are bringing because we're noticing in too narrow a way. We're only noticing the things that they do or don't do that are directly connected to our ideas of vocabulary mastery, of procedural mastery, of making sure that, I've heard people say like, my goal has always been, 80% mastery. I have to get there. Instead of thinking about what students have, what students are bringing, and how I can build on that. For instance, a lot of times I'm giving instruction about that's only about how to respond, how to identify and respond to students' misconceptions. And that's great, noticing misconceptions. I'm not trying to talk down about the research on misconceptions at all, but it's not necessarily going to be enough to create environments that promote good learning experiences for our multilingual learners. Let's see, other things I want to make sure I tell you about this before I have you talk to one another. I think we all are in a space now that we know that we want to stop having deficit views of students. We want to stop thinking about only what they can't do, and we want to start thinking about what they can do. However, that is challenged by this larger social system that we all live in, this larger environment that sort of influences what our brains are even able to notice. And doing professional development like this and building a community with other teachers where you can talk to one another about strengths that you're noticing will kind of grow that part of your brain, and you'll be able to notice more and more and more. And so I want to take a second and just have you go into some breakout rooms for a minute. Maybe like 3 or 4 people. I'm hoping that someone else will set up the breakout room, but I can do it if necessary. And I'd like you to think about not only what you were taught to notice, but how you've been socialized as a professional educator, right? Like, what are the kinds of conversations that go around? What are the sort of social expectations when you talk about your students learning? What does that socialization look like? And how have we been taught, how have we been socialized to notice? And in particular, what do we notice? What do we attend to? How do we interpret what our students are doing? How do we decide what to do next, right? So I want you to sort of brainstorm a little list of some of the ideas, and then we're going to come back, talk about those, and then practice with some actual student work. So is there someone else who's going to set up a breakout room for me, or should I do it? I don't know if I have the power to do that.
I can set it up for you. How many breakout rooms would you like?
Can you just make it so there's like 3 or 4 people per?
Yep, I sure can. Give me 1 second.
For maybe 4 minutes since we started a little late. I have a puppy crying piteously outside the door to my office right now. She's very sad that she wasn't invited to the conference.
Aw, you said 4 minutes?
Yes, that'd be perfect.
All right. And everyone, it'll give you 60 seconds I'm going to set it for 3 minutes and you get 60-second warning. All right, here we go.
Come here. If you're gonna be in my meeting, you have to behave. Come here. Yes, you're a very good dog. I have her.
Aw,
She's like, oh, what you're doing is boring. I don't want to be part of it anyway.
I think we just got a couple more people in the waiting room. Let me let them in.
Hey, you can't bark again if I let you back out. That's the rule. Go. Come here. They're in a breakout room, so this is okay right now. Maybe.
Julianne, did it give you an option to go to a breakout and you just didn't go?
Exactly. Yeah.
Okay. So we, the system we use at DOE is WebEx. So this is like, the first time that I've ever just hosted a Zoom meeting, which, luckily all those skills are transferable. But it's funny because they do work slightly differently.
Mm-hmm.
So like in WebEx, I can control, like I could take you and move you out of the breakout rooms.
Yeah. You can do that in Zoom also, as the host, or if you had made me a co-host, I could have fiddled with those
Right.
things. But we're gonna go into breakout rooms one more time.
Okay.
After we watch a video. And so.
You want the same number of rooms?
Yeah, they can even be in the same room. So if you like, when you click on breakout rooms next time, they'll still be in that organization.
Yeah. I just won't reset it. I'll just restart it.
Exactly.
All righty.
And they should be, how much, can you see how much time they
Yep.
have?
They're coming back in 47 seconds.
Perfect.
Oh, and here's someone else in the waiting room. There we go. They'll be back in 20 seconds.
Okay, I think that we're all back in this main room now. Thank you very much for taking that opportunity to chat with one another. And I'd like you now, if you would, you can like unmute and talk, or you can type in the chat, whatever you're more comfortable with. But I'm wondering if I can get some ideas of what came up in that conversation. What have you been socialized as a professional educator to notice about your students? And as you do, as we share, I want you to think about whether or not these are like deficit-based views where we're focusing on what students can't do or don't know, or if these are strengths-based views where we're focusing on what students can do and do know. So in the chat, please, or speak up any ideas that came up. So their learning styles and preferences can be a strengths-based view, right? But we're also really focused on what they're doing wrong. Every time they complete an assignment, right? And we go through and check it, we mark what's wrong. We look for the places where they haven't done it exactly. people are noticing about their engagement. Are they engaged? Their prior knowledge. The chat's going by fast now. Thank you. Yep. Yep. I'm seeing a lot of folks talk about how we're really used to focusing in on what students can't do. And then a little bit more and more people are saying things like, how are they showing understanding? What are they, how are they learning best? I think it's very natural as teachers in our cultural context that, you know, as I was learning about this framework for professional noticing, it really resonated with me as I thought about, you know, there's so much input all the time coming into our brains that when we're doing something, our brains have to decide what to notice, what to focus on. And as a teacher, we're just sort of socialized into focusing only on what students are doing wrong. So, you know, if a student is chatting, if a student is moving in a way they're not supposed to, if a student is displaying some sort of understanding that isn't consistent with what we were expecting in that moment, right? Then we notice only the sort of negative things and try to fix them. And it's not necessarily an evil. If a student has a misconception, it is part of our work to help them learn something different, right? But there is some trouble when we are trained only to focus on those deficits that students bring, because then we are not able to build on the strengths that students do bring. So that's why this is a green box. I want you to think about when you're noticing strengths, it's not to say that you should ignore things that students do wrong, but it's to think about how strengths can be like building blocks to build towards the content knowledge or the content disciplinary practices that we want students to use. Both the math standards and the science standards talk a lot about the practices, the math practices or the science practices that we want students to be familiar with. We want them to argue with evidence. We want students to generalize. We want students to think about what it means to experiment, right? And those ideas, those practices are themselves social practices that we learn together. And when we notice students' strengths, we can use those as building blocks to help build towards the disciplinary practices that we want them to have. So, and yes, I just saw just the fact that they're learning multiple languages is a big win. Sometimes we forget that what a triumph it is for these little humans to be speaking different languages and going to school in a completely unfamiliar language is quite impressive. So yes, thank you. Thank you, everyone. Let's see, I want to go. There we go. So what I want to show you next, and this is going to be, you'll let me know if you can't hear it, please. This is an old video. It's a classroom in California, a third grade classroom. So like 7, 8-year-old students, and they're doing a lesson on classifying shapes in geometry, right? And this is a bilingual classroom where the teacher sometimes teaches in Spanish and sometimes teaches in English. And the students are all Spanish speakers at home. So we're going to watch we're going to watch it twice. And then I'm going to send you away to talk about it. So the first time through, you can just absorb, you know, the video quality isn't always amazing and there's so much to see, right? So we're going to watch it through once where you just get the idea of what's happening. And then the second time through, maybe be jotting down what are some of the things that you're noticing, and think about, are you noticing strengths? What are strengths that students are bringing? So let's try this.
Today, we are going to have a very special lesson in which, boy, you're really going to have to listen. You're going to put on your best listening ears, because I'm only going to speak English. Like anything else, only English. Let's see how much we remembered from Monday. Fold up your rectangles high as you can. Okay, good. Now, who can describe a rectangle for me? Eric, can you describe it? Can you tell me about it?
A rectangle has two short sides and two long sides.
Two short sides and two long sides. Can somebody tell me something else about this rectangle? If somebody didn't know what it looked like, how would you say it?
Parallel.
It's parallel. Very interesting word. What does parallel mean? Wow, that's a pretty different word, isn't it? Parallel. Can you describe what that is?
Never get together. No. They never get together.
Okay, what never gets together?
The parallel, when they go higher, they never get together. Yeah.
Very good. So that means that the rectangle then the sides will never meet. Those sides will be parallel. Good word. Excellent.
All right, so I'm gonna back it up and let you listen to that explanation and that little bit of the lesson one more time. We don't have to go all the way back to the beginning where they introduced the players, but we are going to be focusing in on what Julian is saying and how the teacher is responding. So we're gonna listen one more time, and now that you've got an idea of what they're talking about, think about jotting down some ideas, because you're going to go into breakout rooms in a minute and have a professional conversation about what you notice, right? So here we go, number 2.
Anything else? Only English. Let's see how much we remembered from Monday. Hold up your rectangles high as you can. Okay, good. Now, who can describe a rectangle for me? Eric, can you describe it? Can you tell me about it?
A rectangle has two short sides and two long sides.
Two short sides and two long sides. Can somebody tell me something else about this rectangle? If somebody didn't know what it looked like, how would you say it?
Parallel.
It's parallel. Very interesting word. What does parallel mean? Wow, that's a pretty different word, isn't it? Parallel. Can you describe what that is?
Never get together. No. They never get together.
Okay, what never gets together?
The parallel, when they go higher, they never get together. Yeah.
Very good. So that means that the rectangle then the sides will never meet. Those sides will be parallel. Good word. Excellent.
And good work and excellent for all of you as well. So as I send you into the breakout rooms again, and these get set up, here's just a little transcript you can take a quick look at. You could even take a screenshot of it if you wanted to have that on hand while you were in your breakout room discussing what you notice about this interaction. And you can also notice what the teacher does, or think about how you might have responded in that moment, and thinking about how we're trying to notice students' strengths today. Does anyone have a question before we head into those breakout rooms about what you're supposed to be talking about? All right, great. So if we can open those breakout rooms again, and y'all can discuss what you noticed in this math classroom with third graders.
Julianne, same 4 minutes?
Yep. Yeah, do you think I was going to say 5? We can do 5 now, I think. 6 my original plan now that we're cruising.
Sounds good.
Hi, I've been trying to come in since 12:30. Did it change or something?
I don't know. I know that there were some struggles with the tech at the beginning. I also wasn't able to get in right away.
Oh,
Yeah.
Okay, well,
Yeah, so everyone's chatting in breakout rooms right now. Did you just get in?
I just got in and it
Well,
says join room 10.
okay, cool.
I'm like, okay, at least I can join, come for half of it. Thank you.
Mhm. They just watched a video that was some third graders talking about classifying shapes. And so they're looking at this transcript and thinking about what they notice. But I think.
I have been keeping an eye on the waiting room and letting people in as I see them, but it's possible that she
Yeah, you
went
missed her.
away and came back. I don't know.
Yep, it's all right.
Yeah.
It's really amazing that we have the ability to have these conversations across thousands of miles. But
I know.
sometimes it's also, I feel like a chimpanzee just punching buttons trying to get my reward.
That's an excellent way of describing it.
Yeah, nothing makes me feel more like a chimp than my smart devices.
I know. So, so true.
And do you now see, like, is it full screen for you, my screen, or is it smaller with stuff behind it?
Nope, it's full screen.
Okay, great.
Yep. Yeah, you're showing me a Google Doc right now.
Great. Yeah, with the transcript.
Yep.
Perfect. Perfect. Perfect.
It's so funny when you're doing breakouts is when I start to realize how long 5 minutes really is.
I did a ton of teaching of undergraduates in the last few years online and have really gotten like pretty good at juggling the breakout rooms and everything. But it is funny, you just sort of, it's that teacher moment that you don't get in the classroom where you just sort of breathe and hope they're all doing it. And it looks like, are people coming back in?
A couple people are rejoining. They were probably finishing their conversations, but there's 34 seconds until everyone comes back.
Okay, perfect. Thank you.
Yeah.
Is it cold in Delaware?
Today, no.
Nice.
It's quite warm today.
Spring is springing. Finally, we've been getting rain nonstop for like 3.5 months. And finally, the flowers are blooming.
Yeah, we've had a couple of days where it's been warm and then back to 30
Oh,
and
yeah.
then warm again, but we're hopefully in
Transition
for a
time
streak
where-
now.
Yeah, winter and spring are having a fight.
It was
That's
so
right.
nice today. I got to take my cat for a walk in his stroller.
That's awesome.
I love that. Okay, I think we're all back now. So I would love to have a conversation about what we're noticing. Yeah, can the person who just put that circle in start us off? What are you noticing? If you're willing
Yeah,
to.
yeah, sure. So I was just circling that because the teacher was able to use a cognate that the student provided and simply just rephrased it in English for the class.
Yeah, exactly. So here's an example of a strength the student brings, right? Their home language. In some settings, we thought the best way for students to learn English is to just outlaw the use of their home language in the classroom. They need to only speak English. But, what we're teaching students isn't only English. We're also trying to teach them mathematics concepts and practices, science concepts and practices, and their home language is a resource for learning those things. So this teacher really skillfully, I think, did what's called revoicing. And revoicing is a talk move that you might have heard of before, in which we sort of restate in the language that we want to promote, right? The English here, the student's idea. So paralelo, paralela, he said too, right? What else are we noticing? What else did you talk about?
Hi. We noticed, I noticed that, I say we, that the teacher provided corrective feedback without correcting the student. So kind of like validated what the student was trying to say and said, but also let them know exactly what the proper terms or correct terms were, but didn't say, oh, you're wrong, or that's not how you say it. And so I like that part.
Yeah. I'm currently learning to speak Spanish. My mother-in-law, who's a Spanish speaker, lives with me. And it's very helpful when I say something, if everyone acts like I said it correctly, but then repeats back to me with the correct word or the correct pronunciation, because then I'm not sort of shut down, but my brain heard it. And I slowly but surely, I start to use the correct conjugations because I'm hearing them. So it's really helpful. And it feels very natural, right? And conversational. This teacher it doesn't sound like a correction in any way. It sounds like the teacher's like praising and building on the students' ideas there. Yeah, Suzanne was talking in the chat here. He used his hands to show parallel. So in this situation, the gesture was a resource that Julianne used as well to help communicate his ideas when he was running his fingers over the top of the rectangle, right? And then moved his fingers past the rectangle to show that the parallel line keeps going. What else is popping up in this chat? Yep, the teacher used a lot of wait time. Yep. And Jackie's talking in the chat about how even though the student doesn't have the precise exact academic vocabulary that we do, of course, want him to move towards in time, he is showing that he's developing some conceptual understanding. That's a really important aspect of classifying shapes. It's very tempting as educators, and especially as educators of multilingual learners, to overly focus on precise vocabulary, to think if they don't have the word, they don't understand the concept. And that's a little bit of a trap. But it's also a trap to go too far the other way. We don't want to say, oh, it doesn't matter if students learn the vocabulary or not. That, of course, is important too. We want to move students towards having the English vocabulary. That's one of our goals as teachers of multilingual learners. What we need to do is balance what we notice and see how the thing that they're doing is a stepping stone towards proficiency, towards conceptual understanding, towards fluency in the language, and that it's not an either or situation. Anything else you want to point out? Clarifying questions?
I like how the other little boy that was sitting next to him, he was agreeing. Maybe he didn't have the vocabulary to say it, but he was agreeing with the little boy that had the shape.
Absolutely. Someone typed in the chat earlier about the silent phase. That, there are times as you're learning in a new language that you're not ready to put all of your ideas into words spoken out loud or written down. But it doesn't mean that you don't have any ideas in your head. And it doesn't mean you don't have a developing understanding. And the way Antonio was leaning in and saying, yeah, demonstrated to me, at least as an instructor, that at the very least he was engaged, right? And seemed to be supporting Julianne's argument. He was watching the fingers, right? And so we want to notice that as well. Okay, Antonio seems to be building towards this idea as well. Anything else before I tell you what I think? All right. So you noticed a lot of the things that I wanted to point out to you. So congratulations on that. You're on it. I just want to point out mathematical practices over here on the right side of our screen. I think that for me as an elementary teacher of math, it's a lot easier for me to think of the procedures and the concepts that I want students to know. And it was a little bit harder to think about practices. I think maybe because they were newer when I was teaching and I didn't have as much professional development around them. But I think they're also tricky because they're broad and are applied in many different situations and are going to look different in different situations. But the math practices, disciplinary practices, are a really important part of learning to do math. And these are the things that they're going to do at every level throughout math. When we get to algebra, we're also abstracting and generalizing. When we get to trig, if you get into calculus, you're abstracting and generalizing are really important disciplinary practices in mathematics, right? And so we saw Julian abstracting when he talked about the lines going past the dimensions of the rectangle. So that was abstract, going off into an imaginary space and that they would never get together. And then he was also generalizing about all parallel lines. The parallel lines, a property of them, of all parallel lines, is that they never meet, right? And so as an instructor, we want to notice when students are doing things like abstracting, generalizing, supporting their argument with evidence, things like that, because these are the sort of cultural practices of the discipline that we want to enculturate the students into. This is the way mathematicians think and talk and do math with one another. They abstract, they generalize. And so if we can start to notice when students are doing them, and then even begin to name and praise and encourage that behavior, we're going to help our students develop a sense of agency in mathematics, a sense that they can do mathematics, that they can participate in this. And we start to develop that culture in the classroom where students are doing mathematics instead of just obediently trying to follow our instructions. Our next one is a short one. I think I'll do because we're coming up on the end of our time here. This is a short science example that I'm mostly going to talk you through because of time. So there was a 7th grade classroom and they were discussing the classifying of things into living or non-living things. And they had a discussion, is the sun a living thing? And one student who was from a marginalized community, right? He wasn't part of the dominant group. He argued that, it didn't make any sense for the sun to not be a living thing. The sun should be in the living thing category because it provided life to all living things. So why does it make any sense for the sun to not be in the living category? And the teacher in that classroom shut it down, and the other students as well, like, no, you're wrong. It's not alive. It's a non-living thing. And the student sort of then retreated, right? And was like, well, no one seems to be understanding my argument. And I want to draw your attention to this because within the classification system that was the purpose of the lesson, the teacher and the other student were correct. The sun is not a living thing. And yet what the student was doing was thinking about systems and thinking about how things are related to one another. And this sort of systemic thinking is a part of the NGSS standards, is a disciplinary practice in science. How do things work together? How do these systems that create life and maintain life interact with one another? And that could have been an opportunity for that teacher to build that student up and to demonstrate to others that their thinking had value and was an important science disciplinary practice, right? Thinking about the interconnectedness of things, thinking about how systems work. And furthermore, microbiologists are extending our definitions of what life is every day. Cutting edge scientists are coming up with new ways to think about what is life. And so when we very rigidly adhere only to our categories and our definitions and don't let students think those bigger ideas, we are also keeping them from participating in science as it's happening today in our world. Again, I don't want to leave you with the idea that it's not important that students learn the words, learn the concepts, learn the procedures that are part of the standards. These are all really important. My argument is that if we focus on the practices that students are engaging in and the strengths that they're bringing, what they are doing and connecting those to the practices, we build a culture in which students are authentically participating, right? In mathematics, in science, instead of being shut down because their idea wasn't consistent or their language wasn't sufficient to communicate the idea that was expected. These are the 3 recommendations that I'm going to leave you with, and they go in both directions, right? So as a teacher, I might think about starting from the bottom. I need to notice, I need to work on my ability as a professional to notice strengths, because I know that I've been socialized and enculturated to notice misconceptions, to notice where students go wrong. And while I don't want to get rid of that entirely, I also want to build up my muscle of noticing the strengths that students are bringing, because then I want to connect those strengths to the disciplinary practices. And that is the essential key to promoting learning in STEM for our multilingual students. We need to connect those. It's not enough to say, oh, you're using your home language, that's great. Or you're thinking about systems, that's cool. You're thinking differently about the sun, that's interesting. We want to connect that to what mathematicians do, to what scientists do. And that's going to require up at the top, that idea of an expanded notion. And what I mean there is we need to broaden our idea about what it means to be doing math and science. Especially as teachers, we tend to have a very rigid view because we may not be mathematicians or scientists ourselves. So we ourselves may have a limited understanding of what it means to participate in those disciplines, right? And so we need to expand our ideas of what counts as doing math. There's a great paper by Nicole Louie that you might look into, where she talks about a teacher learning to notice all the things that help make a student good at math, all of those practices that are essential for success in mathematics. And many of them are not memorizing my mathematics facts, my multiplication facts, or having the precise academic vocabulary for things. Many of them have to do with perseverance, asking questions, clarifying, using technology, using your resources, right? And when we start to notice those other things that students are doing that are connected to the doing of math and science, the being of a scientist or mathematician, then we can create these environments where students are more successful and are more like supported for learning. That Nicole paper I can draw. It's 2018, I think. Let me find it for you. Yeah, it's a 2018 paper. I can't remember the name of it off the top of my head right now. And also you'll see this paper that I have here at the top for you is the chapter that my colleagues and I wrote that this presentation is built from, and it has that citation in it as well for you, so you can look it up. And we're almost here at 10:30. So does anyone have any questions for me? And I can go back to this slide, which is, I think, our most important one of what we're arguing are the 3 things we need to do to start shifting our focus to be noticing for the growth of our multilingual learners. Yeah, I see some great conversation, some great debate about the sun happening in the chat. And think about how having that conversation is growing your ideas about thinking on the boundaries about what life is and what it means, and challenging your own categories and your own reasoning from the evidence of your experience. Those are all science practices, right? And so instead of just saying, no, you're wrong category, I need to show on the test that you can categorize living and non-living things. You've shut down a whole avenue of discussion and a whole opportunity for a student to participate in scientific thinking, which is really our goal. Anything else?
I would say my mind is blown because I thought I need to go back to science class. I thought the sun was living. I agree with the student and the earth. What's going on here?
Absolutely, right? And if we think about what are these definitions and categories that we create, they're all created by humans. We're just trying to make sense of our world. And those categories and those definitions have evolved over history and probably will continue to do so, right? And so if we can focus on noticing the amazing thinking, or noticing the reasoning or the use of our everyday language to explain a complex idea, or the use of our gestures to support us, or whatever it is, what we're doing is supporting students to build them towards where we want them to go. And then when we think of what that goal is, we need to be more open-minded than just our standards, than just our assessments, but think about what it means to be doing mathematics, what it means to be participating in science, right?
I agree with the participant who talked about it before. I think if we teach kids in science that suns can die, then we must also uphold the thought that sun is alive.
Yeah.
I really appreciate this. I just found out that the sun cannot die because it's not big enough. I'm in integrated science, but a lot of our, MLL students, they are on a second, third grade level. And so we just had the test Friday, and it was like, no, the sun cannot die because it's not big enough. It's not alive. It's not actually big enough. So it will never go through the stages of a stellar star, like the white dwarf and eventually a black hole.
I didn't know that. That is really interesting. I thought
Yeah.
the sun would eventually get there.
Nope. And this is
That was a
11th grade
fact.
integrated. Yep. 11th grade integrated science. So I learned something new as well, because I thought it was alive. I thought it would eventually die as well.
Absolutely. Any other thoughts? Okay. Well, fantastic. It should be 1:30 for y'all, so you have another thing I think to go to, but I very much appreciate all of you. And you have my email and my contact information, and that chapter is available for free online. You can get